Hello. So today we are going to talk about mean versus median and which one is better. Now, this is a couple of pages forward in your notes from where we left off last time. So we are in a section about numeric data and specifically what it looks like when you display it. So we've been talking about different graphs like histograms and dot plots and stem plots and box plots, and also describing them. So we use this idea of SOCs to describe two graphs or describe or compare them. One of the things we talked about was shape. Graphs can be unimodal or bimodal, meaning if they have one peak or two peaks. We talked about graphs that are uniform. They're all kind of the same height. And we also talked about whether or not they were symmetric or they were skewed and what that tells us. So if a graph is symmetric or skewed, and if it's unimodal, that can actually tell us and guide us in what direction we should use to decide how to talk about center and spread. So remember, shape, outliers, center, and spread, SOCs. So center is usually a mean or a median, and it's this one number that we're used to kind of describe what the data typically is. So typically the center is this number. So we're describing the whole data set with this kind of average number. And the median is the central value, and the mean is that arithmetic average where you add up all the numbers and divide by how many there are. The spread number talks about how wide the graph is and what the story the data is telling about variability. How different are the numbers from each other? So, for example, one way to talk about spread is range, literally how wide the numbers are from, or how wide the graph is from left to right. So the maximum value minus the minimum value. We've also talked about interquartile range. Interquartile range is the difference between Q3 and Q1. It's that middle 50% of the data. And then finally, one other kind of spread is standard deviation. And standard deviation, we'll talk about next time. It's the measure of spread around the center with respect to the mean. So how do you decide which measure of spread and which measure of center are best? So let's take a look at a couple of scenarios. So I have, how am I doing in this class? Mrs. Schmidt looks at the grades for a previous assessment for two students. So we have student A, and here's all their grades, and student B, and here's all their grades on the right. Student A has a mean of 90.95 and a median of 90. So on average, if you took all their grades and divided by how many there were, they get 90.95. And if you were to line up all their grades in a row and find the center one, you get a median of 90. Student B has an arithmetic average of 87.38 and a median of 90. So that means if you add them all up and divide by how many you are, you have 87. And that central value, if you lined them all up and found the exact middle, you'd have 90. Now there's an interesting thing going on with these two graphs. Student A looks basically unimodal. If you were to draw a curve over that, you would end up with kind of a unimodal graph, sort of one peak, and it also looks approximately symmetric. So if you folded it, it's pretty much the same on both sides. It's not exactly perfect, but it's okay. The other thing I noticed about student B is that while it's got this outlier down here on the left, and if I was to draw a curve that sort of encompassed that outlier, we're going to see a really heavy skew to the left in this case. Remember, the skew always goes in the direction of that tail. So it's unimodal, it's skewed to the left, and it has a low outlier. And even if we didn't have that outlier, we're still seeing kind of this skew on the left as the 3 bars here versus the 1 on the other side. The other thing we notice when we're dealing with these values is that with student A, the mean and median are really close to each other. 90.9 and 90, those are pretty close. Whereas the other student, when I look at them, they have an 87 and a 90. So the middle is still hanging out right here around 90, but the average is a lot lower. And maybe the reason why the average is lower is because they have this low score, this really low value. I mean, you've seen that happen before, right? You have a whole bunch of grades, and then you come in and you like tank a quiz or a test, and the whole average drops down. Or you have grades, like you have a whole bunch of 70s and 80s, and you come in and get a 104 on a test, do a really great job, and your average kind of raises based on that. So here's what I noticed in student A, where we have that symmetry. We're seeing that the mean and median are similar. And when the data is skewed to the left, instead, we're seeing that that mean, that arithmetic average, is lower than that median. So when we're looking at data, the shape can actually tell us what to kind of expect about mean, median, and mode, for example. And one thing I do notice is that when distributions are skewed, those extreme values in the tail, those really low numbers or really high numbers, tend to pull the mean in that direction. So the mean follows the skew. The mean follows the skew. So in a situation like here on the left, this is skewed to the left. We got that tail over there on the left. And what we would see is that the mean would actually end up being less than the mean to the left of that median. And when I have this one on the far right that's skewed to the right, the mean follows that skew. And so when it's skewed to the right, the mean ends up actually to the right side of that median. So the mean is greater than the median when it's skewed to the right, because the mean is literally on the right, on the number side, on the number line. And when it's skewed to the left, the mean is literally on the left. So it's following that skew, so the mean is actually less. And in a situation where you have a perfectly symmetric graph, the mean, median, and mode are pretty much all in the same spot. So in an approximately symmetric graph, usually your mean and median are about in the same place. Okay, so in general, how do you decide which one of these measures of center or spread is best? So in general, we really prefer the mean over the median, if at all possible. So mean mathematically is very superior. Mean uses every single number in the data to try to figure out what we should do. So it actually uses every single number. Every number is included. There's an arithmetic formula. You add them up, divide by how many there are. I can express that algebraically. The median is more of a concept. So the median really only is concerned with the values in the middle. It's this balance point. There's no real formula for it. There's a different way to find it if there's an even or odd number of things. So it's not a very scientific center. It's not a very mathematical center. So we don't really like median a lot, but it does have its advantages. And here's what those advantages are. If your shape of your graph is symmetric or even roughly symmetric, most of the time you're going to want to use the mean as your measure of center. Mean is very superior in this case, mathematically speaking. So if your data looks symmetric, then you would expect to use the mean for that value. And if you're using the mean, the measure of spread that is associated with mean is standard deviation. Standard deviation tells you on average how far your numbers are going to be away from the mean. Now, if your data is skewed, or if it has really extreme values like low values like outliers or high value outliers, okay, so if you're seeing a really strong skew or you're seeing outliers, we tend to say that the best measure of center is median. And the reason why is because the mean is really affected by these outliers. Take, for example, let's say that you had a whole bunch of 90s in a row, 90%, 90%, 90%, 90%, whole bunch of 90%, but then you come in one day and you get a 30% on a test. Ooh, painful, right? Well, what's going to happen to your average? Your average, you have a whole bunch of 90s, then you get this really low 30%. That's going to really tank your average. It's going to pull your average towards that outlier. So your average is going to be lower than 90%. But if you have a bunch of 90s and then one really low value, your median is still going to be 90. So if I'm looking at a whole bunch of 90s plus one really low value, and I wanted to describe how you were doing in the class, are you really a B student or are you really an A- student who had a bad day? So a lot of times when we're expecting that skewed data or we're expecting those unusual values, the median does a better job of saying what's typical of the data than the mean is. All right, so we're always looking for that typical value. So in general, if you see graphs that are symmetric, or roughly symmetric, then you're going to want to go with a center and spread of a mean and a standard deviation. And if you see graphs that are skewed or have outliers, you're going to want to describe center and spread using that median. Now, for example, let's say I have this dot plot here. It says, what would you expect, the mean or the median to be larger and why? All right, so just based on this dot plot, because I don't want to actually add these numbers up and figure this out, I noticed that this graph over here has a right skew. Now remember, you're going to kind of sketch this thing over here to kind of see this. Goes all the way over those outliers on the right side. So this is likely skewed to the right. Okay, so skew to the right. So what I know is since it's skewed to the right, the mean is going to follow the skew. And if the mean follows the skew, that means the mean is going to be to the right of the median, which means the mean is going to be larger. Also, if I'm looking at this graph and I see that it's skewed to the right and I get to choose how I'm going to talk about center and spread, I should choose median and interquartile range, because median and interquartile range are more appropriate measures of center and spread to talk about skewed data or data that has outliers like this does. All right, in this next picture, it says, what measure of center and spread would be most appropriate to talk about this data? So I look over here and I think about drawing like a little curve over this, and it feels fairly symmetric. Okay, so I would say this is approximately symmetric graph. And so anytime we have approximate symmetry, even if it's not perfect, if we're not seeing that heavy skew and not seeing those outliers, then the measure of center and spread that we prefer would be the mean and the standard deviation. Also, if you were going to ask me at this point, what would be bigger, the mean or the median? I would expect them to be about the same. Anytime you have a symmetric graph, that mean and that median tend to be pretty similar values. Okay. Now, one other thing you have to be able to do is find a mean of weighted data or of a frequency distribution. So if you ever see a situation like this, so data set 1, I have the number of siblings, 0, 1, 2, 3, 4, 5, and then how many people answered this. Now, visually, what you should imagine is happening when you're looking at an example like this is that I'm trying to find the average number of siblings, and this tells me how many of each of these I had. So as a picture, if you look over here on the right, here's a little dot plot of that. So notice I've got 0, 1, 2, 3, 4, 5. There's my siblings. And then I have 5 zeros and 13 ones and 18 twos, etc. So if I wanted to find the mean, one of the things I need to do is add up all the numbers and divide by how many there are. So remember, if there's 5 zeros and 13 ones and 18 twos and 19 threes, etc., then these counts add up to 73. So there's really not like 6 numbers involved here. There's 73 numbers, and we have a lot of repetition. So I need to add up what all of these counts add up to and then divide by that 73. Now, if you want, you could take your calculator and say, okay, I have 0 5 times. So I could go 0 plus 0 plus 0 plus 0 plus 0. 1 plus 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 1. But that's a waste of time. So remember, if you're doing that repeated addition, it's faster just to do multiplication. So I have the number 0 5 times, plus I have the number 1 13 times. That's the same as saying 0 plus 0 plus 0 plus 0 and 1 plus 1 plus 1 plus 1 plus 1, etc. I can go further on. There's the number 2, I've got 18 of those. And the number 3, I've got 19 of those. And the number 4, I've got 15 of those. And the number 5, I've got 3 of those. So if I put all of these together, I get 181 in my calculator. So that's the same thing I would get if I would be to individually add up like all these dots. 0 plus 0 plus 0 plus 0 plus 0. 1 plus 1, 1, 1, 1, 1, 1, 1, 2, 2, 2, 2, 2, 2, 2. Right, all this stuff there. So I get that 181 divide by 73, and I get 2.48. And I should always stop and ask myself, does this make any sense at all? So if the number of siblings is something between 0 and 5, would it make sense to have an average of 2.48? Is that possible? Yeah. If I end up with something like the average is 9, that doesn't make any sense because it's outside that range of possibilities. Now, in order to find the median, what we would want to do is imagine all of these numbers lined up in a row. So I have 5 zeros and 13 ones and 18 twos all lined up in a row. And I know that there are 73 numbers. So to find the middle number, that's an odd one. So let's think. If I take one away, that's 72. Half of 72 is 36. So if I have 36 on the left and 36 on the right, there's 72 numbers, and there'd be 1 in the middle. So what I'm looking for is where is number 73? No, sorry, where is number 37? So I would start over here at the side of the count. I know I've got 5 zeros. And then after that, I've got 13 ones. So 5 zeros and 13 ones, I'm currently at the 18th number. 5 plus 13 is 18. Then I have another 18 twos. So if I go the 18 numbers I already had, plus another 18, now I'm at number 36. I'm looking for the 37th number. The 37th number is going to be in that next pile of numbers. That's going to be a 3. So the median there would be a 3. Or you could draw a little picture like I have over here, and you could count and see when you found the 37th dot, and it's going to land on that third number there. Now, the next question said, which measure of center and spread would be the most appropriate to describe the data? So I just made this little sketch over here, and I noticed that this is basically approximately symmetric. So since it's approximately symmetric, the best measure of center and spread would be mean and standard deviation. Okay. Now, in this next example, same thing, but a little bit different. So I've got the mother's age, which goes from 38 to 44. I've got that little picture over to the side. And then I've got 1 of those and 2 of those and 5 of those, etc. So if we sketch this guy, we end up with this really heavy left skew. So one thing I know is that since there's a strong left skew, the median would be a more appropriate measure to report as the measure of center. And the IQR would be my measure of spread. Because if I have a skewed distribution, I would expect that the median is a better representation there. Now again, to find that mean, I know that I'm going to have 1 38 and 2 39s and 5 40s, etc. So instead of going 38 plus 39 plus 39 plus 40 plus 40 plus 40 plus 40 plus 40 and adding it up like that, I'm just going to multiply to make it faster. I have 1 38 and 2 39s and 5 40s, etc. Okay, I add each number times how many of those I have. There were 67 numbers total, so we divide by 67 and we end up with 42.57. Okay, for the median, 67 numbers, so I do half of that is like 33 and 33 is 66, and I want that 34th number. So I got 1 and 2, that puts me 3 numbers, another 5 gives me 8, another 7 gives me 15, another 10 gives me 25. I'm looking for number 33. Okay, so the next pile has 19 in it, which means that would put me all the way up to 44. So I know that 42 was not quite there. I needed to get to that 34th number, which would be in that pile of 43s. So that would be my median in that case. Okay. If you have any questions, let me know.